So we're going to go ahead and talk about data types. Data types, again, are the kind of value that you want the computer to be able to store. You want it to be able to store it in memory so that it can recall it later. And you need to tell it how much space to remember and what type of data you're saving in that, what type of value it is, such as, is it going to be within a certain range? Is it going to be just a 1 or a 0? Is it going to be between 0 and 255? Is it going to have negatives involved? Are there going to be decimal points involved? Those are the types of things we're looking at here. So if we want to start off with the smallest data type, the smallest data type is already in here. It's a void. Now a void just means there is nothing to save. That's giving it a heads up saying you're allowed to use this, you need to know what's going on, but you're not going to need to save a value into it. There's nothing there to save. Now we're going to move on to actual ones where we want to save things. The next one would be the Boolean. And you'll see that when you type these out, they change color, and in this program they change kind of to a bluish color. So a Boolean, what it's going to do is it's just going to save a 0 or a 1. That's it. Now what is a 0 and a 1? Why would that be important to save? Because a 0 and a 1 is the same thing as a false for 0 and a true for a 1. It would also be a 0 for a no or a 1 for a yes. It would also be a 0 for off or low, and it will be a 1 for on or high. So if I just need to save something simple such as a button press, or to check to see if something's on or off, or to see if something's true or false, using a Boolean would probably be the best choice. Now I'm going to put some information here in comments. A 0, we'll just do this, 0 or 1. All right, so the next one that I want to look at, we talked previously about, it's a byte. A byte is a string of zeros and ones, and it's 8 of them together, so it would be similar to 8 of these guys in a row. And when you do the math, when you have your binary, your 0 and your 1 number system, and you have 8 digits in there, the smallest number you can have is a 0, and the largest one would be 255. Now it's important to remember that what this is really holding here isn't only just a value between 0 and 255. There are 256 spots of information here. Since we're starting at 0 and we're ending at 255, if I were to count how many spots it can save, how many different values it can save, it would be 256 values. Both of these are very common, and we're going to do another common one that you're going to see a whole lot, especially if you follow along with any online tutorials. It's kind of the default people like to use with Arduino, and that would be the int. Int stands for integer, and so this would be if you want to hold a whole number value that's larger than a byte. I don't remember the actual value. Let me pull up OneNote. I have a, let's see, where would I have put it? There it is. So these are the different types. So maybe I'll just look off of this one from here on out. These are the different data types that we can look at. Now, these aren't all of them. These are some of the most basic ones that you're going to want to use. There are some variations of them. And so let's just talk about it from here. We already talked about the Boolean. It's 1 bit, right? Just one digit, either a 1 or a 0. And it holds a 0 or a 1. Maybe I should change that to an or. Guess it doesn't matter all that much. No decimals, so it's just the whole numbers. A byte is 8 bits, and it holds the value from 0 to 255. Again, no decimals. So here's the int, int. It's 16 bits in Arduino, And it can hold positive and negative values, but it will not hold a decimal. So the possible values that it can hold are anything from, at the lowest, negative 32,768 to positive 32,767. Now let's say I do want a value, if I do want a decimal, right? I want to not just hold the whole number, I want to hold a partial number, something like a temperature, right? I'm going to have a decimal in there. It's not just 72 degrees, it's 72.5 degrees. If I want to do that, I'm going to use a float type. F-L-O-A-T. And it's going to consist of 32 bits of information. And again, these are the possible values. So a pretty small number, magnitude times 10 to the 38, that's huge. And also again, it can go into the negative range, or it can be into the positive range. So it can hold a huge number. Now, it's only going to hold a specific number of decimal places within that. So yes, it can hold decimals. It can write similarly to scientific notation. Right? You can do this magnitude here, times 10 to the 38. But it will also hold 8 digits worth of information, if I remember right. 1, 2, 3, 4, 5, 6, 7, 8. 8 digits of actual information. Then it will also put a decimal place anywhere within those 8 digits. And then it will also have a magnitude value that it can go up to. Now I'm going to change something slightly. This one is also an integer type. It's an int. But if you type the word unsigned in front of something, what it will do is it will make it so that there are no possible negative values. So in this case, it's the exact same size as the int from up here. It's 16 bits. Except for up here, half of those were possible negative values. Here we start at 0. And we still have the same number of spots to save things in. We have 65,536 spots to save things. That's the same number of spots we had up here. The only difference is this one started with negative values and this one starts with 0. If I want to save more information, I can use a long. And what a long is it's the same thing as an int, except for it's 32 bits. So it's twice as many bits as an int, but that twice as many bits makes this number significantly bigger. So if I need to save a really, really big number, then I can use a long. And then also we have characters. If we want to have a character such as a capital A, a capital B, a capital C, a lowercase c, a lowercase a plus sign, and you want it to just be a character, you use a character type, and that's going to be 8 bits. And then you can have characters saved inside of memory. Now the only one of these that I've written up here, and again there are other types, the only one that actually saves a decimal is the float. Now if we scroll down, let me just open this up so we can see it. There are a couple other things we can do. One we talked about, if it is a data type that can hold a negative, if I type the word unsigned in front of it, it will still hold that same number of spots, but it will start at 0. There will not be an ability to save a negative number in it. The other thing that I can do is I can type the word const in front of it. And if I type the word const in front of it, what that means is once I actually save a value into a variable, it's a constant. That means that the number cannot be changed once a value has been saved in there. It locks it shut. If I save the number 10 into it, I can't later try to say, well, I'd like to restore a value into that variable. I'd like to change that variable value. It won't let me do that. It's going to make it a constant. So let's go back real quick. I have an int here. I can make it unsigned. The byte I don't need to make unsigned. The Boolean I don't need to make unsigned because there are no negative numbers already. I can stack other things in here, so I could put const. This is going to be a constant, unsigned integer. It's going to be an integer amount. It's going to only hold whole numbers. It's unassigned, which means it's going to, at the lowest, just be able to hold a 0, no negative numbers. And because we looked over here, that means that it's going to have a maximum of 65,535. And if I type the word const in front of it, once I save something into it, it can't be changed. If I do want it to be changed, I just take that out. I can put const in front of anything. And it's going to make sure that once something's saved there, that will be a constant. Now, a couple really quick things about that. If I... So why do I care what type I use? So the main thing that I want to look at right now is just efficiency. If I want to just check to see if something's true or false, I don't want to take up a whole lot of space in memory. The more memory that I take up, that means that the slower that my sketch or my code, my program could run because it has to cycle through so much memory to do things. Or I'm using up memory that's just useless. It's filling information in. It'd be like saying, I just want to write one sentence, and instead of getting a small piece of paper out, I go and I buy a composition notebook that has 100 pages in it, and I just write one sentence in it, and I say I'm done, I'm never writing anything else in this again because I only needed enough space to write one sentence. It's just wasted space. So what we would like to do is we'd like to learn to be efficient. Again, this is a design class, and so we want to design our things to be as efficient as possible, which means if I know, and you should know because you're the person writing it, you're the one designing it, if you know you only want a 0 or a 1, only a true or a false or a yes or a no, use a Boolean. It's more efficient, it's more clean. If you know that it's going to be between 0 and 255, go ahead and use a byte. Now let's say that the possible values are between 7 and 12. What type are you going to use? You're going to still use a byte. Yes, there's still going to be some overkill, but we don't have anything that we know about right now or in the Arduino language that's going to fit somewhere in between there. So I'm just going to use the smallest possible thing that I could use. Now, if I need to save 3 values, a -1, a 0, or a +1, at this point our best option is to just use an int. Yes, that's a lot of space to just save 3 values, but we're going to need the negative sign, which means we're going to have to use int. So that's the overview. We'll talk about some data types a little bit more, how to use them, how to save variables, how to change variables in a later video.